Hello, my dear students. In last lecture, I have taught you about the inductance. Inductance due to the internal field of the conductor and external field of the conductor. And in last, inductance of the single phase transmission line. Today, I am going to explain about the capacitance of the single phase transmission line. Right? Before going to explain the single phase transmission line, let us consider the electric field intensity due to the line charge. Consider a wire having the length L and small r radius. Consider a random points P at radius small r, and this line having the charge density having total charge Q, and length of this conductor is L. Hence, the enclosed area will be 2 pi RL with this radius and this much length, due to which total charge in as per Gauss law, total charge enclosed will be equal to the Q into L, that will be equal to the D into 2 pi R into L, where D is the field density, and this D is given by D epsilon E, where E is the electric field intensity. You have to be careful here. D is equal to epsilon E. This is just analogy to the B equal to mu H in case of magnetic field circuit, right? And in that case, B was magnetic flux density and H was magnetic flux intensity, and mu was the permeability of the material. Similarly, here epsilon is the permittivity, and E is the electric field intensity, and D is the electric flux density, right? Electric field density. Now we can put the value of D in this equation. Here D is the Q by 2 pi R will be equal to the epsilon E, and hence E will be Q upon 2 pi epsilon R. Epsilon is if the medium is air, then epsilon will be replaced by epsilon 0, right? This formula, you have to remember this formula. Electric field intensity due to line charge will be equal to the Q upon 2 pi epsilon naught R. This is the electric field intensity at radius R due to the Q line charge density, right? Now consider the potential difference between 2 points due to the line charge. This will be simply we will integrate electric field intensity between 2 points R2 and R1. Suppose P1 is at R1 distance and P2 is at R2 distance. Hence, potential difference between these 2 points will be simply integration from R2 to R1 of the electric field intensity E, right? And after the integration, this will come Q upon 2 pi epsilon naught ln R1 by R2. ठीक है, इंटीग्रेशन कैसे है? यहाँ पे आपको फंक्शन हो जाएगा सिंपली 1 by R या 1 by X टाइप. 1 by X का इंटीग्रेशन कितना होता है? ln X, या ln X का डिफरेंशिएशन कितना होता है? 1 by X. ठीक है. Now this similar concept will be used to calculate the capacitance of the single phase transmission line or single phase line. As you know, capacitor. What is capacitor? Capacitor is an electrical device which consists of two metallic plates, separated by a dielectric medium. Similarly, a transmission line is also, so transmission conductor is also metallic, can be considered as a metallic plate, and another plate is considered that is earth surface. Yeah. Now, what is capacitance? Capacitance is defined as the ratio of the charge on one conductor to the potential difference between the conductors. Right? Means total charge divided by potential difference between the conductors. Right? Now, there are two assumptions. They are charge is uniformly distributed over the surface of the conductor so that flux is radial. Yeah, charge must be uniformly distributed. Second is effect of earth is neglected. Earth effect must be neglected in order to calculate the capacitance of the single phase line. Now consider these two conductors of the single phase line. Single phase two wire system. This is the first conductor, this is the second conductor, this is outgoing, this is incoming or returning, right? If the charge density at the conductor of A is q coulomb per meter and radius of the each conductor is r, then electric field intensity will be at distance x will be q upon 2 pi epsilon naught x, right? You have to be careful here. Now the capacitance at point V due to the conductor B, and you know this is the returning current. This returning current means charge will be negative. If this direction is positive, then this direction of current in B will be reverse or negative. Hence, the charge will be considered negative here. And distance between these point B conductor and P point will be simply d minus x. इस d से जब इस x को माइनस कर देंगे तो क्या हो जाएगा? सिंपली P से B की डिस्टेंस. Now electric field density E equal to minus q upon 2 pi epsilon 0 into d minus x. This is the distance. Here the value of x. Here the value of x is d minus x. X was that simply distance between the conductors and the point to be measured. And hence total both the field are in same direction, right? That both direction will be is the same. Hence the total field will be simply sum of the electric field intensity due to the conductor A and conductor B. Hence Ex will be q upon 2 pi epsilon x plus q upon 2 pi epsilon d minus x. And potential difference, you just be careful here. Electric field is the electric field intensity while V is the potential difference. Means the potential difference at 2 points, while electric field intensity there is no need of 2 points. It's simply the electric field intensity. Potential difference will be simply calculated by integrating the 2 points d minus r and r with ex. Then when we will integrate this electric field intensity, this will come like q upon 2 pi epsilon naught ln x minus ln t minus x, and this is the limit. Lower limit is lower limit when the sign is changed, then the lower limit will be R, and upper limit will be D minus R. Yeah. Now this limit has been put in here. Ln D minus R minus ln R minus this x at this point, x will be D minus R, plus plus ln R, sorry, D minus R, and this will be ln R, or sorry. And now if the point, if the value of D minus R is placed here, sorry, D minus R, and when the value of D minus R is placed here, this will be equal to D minus R, D will be cancelled out, and minus R will be still level. Something wrong here. Ex, this will be ln x minus right. Just a second. Okay. Now voltage across A and B will be simply minus D minus R to R Ex dx. Why here is minus? Because charge moves opposite to the electric field, due to which x will be negative. Now after integration we will get q upon 2 by epsilon will be considered as a constant, and here will be 1 by x plus 1 by d minus x. Then integration of 1 by x will be ln x minus ln d minus x. Here x is negative, hence this will be negative. And you are seeing here the minus sign has been disappear, because this limit has been changed, altered, and d minus lower limit becomes upper limits, and upper limit become lower limit, due to which negative sign has been changed. Now putting these limits in this expression, ln x d minus r, and this will be minus ln r minus of ln r, and this minus will be plus here ln d minus r. After solving this will be 2 times of ln r minus 2 ln r, and this will be 2 times ln d minus r. Then you know that in case of ln, it will divided minus sign will go under denominator, and 2 times d minus r upon 2 times ln r, 2 will be cancelled, and it will become q upon pi epsilon naught ln d minus r by r volt. This is the voltage or potential difference between conductors A and B. And if D is very greater than R, means distance between spacing between the two conductors is very large, and D minus R will be equal to D. Means R can be neglected, and D minus R will be D. Then potential difference will be VAB equal to Q upon pi epsilon ln D by R volt. Means D minus R becomes capital D when the radius of the conductor will be very low than the spacing between conductors. Right. Now capacitance between the conductors will be simply total charge on the conductors divided by the voltage difference between the conductors, and we have calculated the voltage difference between the conductors A and B will each Q upon pi epsilon naught ln d by r. Hence, the capacitance between points A and B will be simply Q upon V, and this will become pi epsilon naught upon ln d by r. This formula you have to remember forever. Okay. Now, how two capacitance will be considered if they are connected in series, or sometimes conductors capacitance is calculated with respect to neutral, and if you know the capacitance of the conductor with respect to of phase A with respect to neutral and phase B with respect to neutral, then we can calculate the capacitance between phase A and B by this concept. Simply A and B will be this capacitance with respect to neutral A and N and B and N. This can be simply added in series. Then CN will be equal to CBN. If the line is uniform, charge on that connectors are uniform on each phase, then the capacitance with respect to neutral of this phase will be same. That will be equal to the simply 2 pi epsilon upon ln d by r. Right. Alternate method is given here. It's also very simple. Now the effect of earth on capacitance. Let us discuss also the alternate method. VAB, as you know, the potential difference between the two conductors due to the charge on the conductor will be equal to VAB will be equal to simply QA charge on A upon 2 pi epsilon naught into ln d by r, and VAB due to the conductor B will be charge on conductor B upon 2 pi epsilon naught ln r by t. Right. Now the VAB will be equal to simply voltage between A and B will be sum of the potential at A and sum of the potential at B. Right. This will be simply B will, since B is the returning path, hence it will be negative, and total voltage difference of the Q upon 2 pi epsilon ln d by r minus ln d by r, because Q is negative to the charge here, and it will become finally Q upon pi epsilon ln d by r, similar to this one. This one. Now the effect of the earth on capacitance. What is the effect? This is very important topic from GATE examination and IES also. You know, magnetic field, two poles of the magnet cannot be separated. Similarly, charge, charged particles, if isolated, but it's also assumed that its field, magnetic field, meet at infinite. Suppose this is isolated charge, and this is the line of force or flux is emitting, and we assume that these flux lines are meet at the infinite to its opposite charge. If it's positive, then its opposite will be negative, and this negative opposite charge is considered as known as the image charge. All right. The flux lines are terminating to an imaginary charge placed at infinity. Right. This can be visualized by imaginary charge opposite polarity placed inside the Earth at the same distance h. Yeah, from this is our surface. Suppose this is height h, and its opposite charge or its main charge will be considered at the depth of the Earth uh, at same height of the Earth. This will be h also. Distance from this point to this image charge will be h. And we assume that all the flux lines meet at this image charge, right? Now, if we consider the assumption, then what will be the capacitance of the conductor due to the Earth? Now we can apply the same concept as above. These arrangements similar to the single lines separated with distance 2h means the distance between these two conductors is 2h. This one h and this one also h, and so total distance will be these two conductors plus and minus charge will be 2h. And suppose the radius of this charge is r, then the capacitance can be given as a 2 pi epsilon naught ln 2h by r as the previous concept. If this is a single charge, now if there is a conductor, there is phase, means there will be two conductor, one phase conductor and another is p, and the image conductor can be considered a dash and b dash, right? And charges on that conductors will be b a dash and b dash will be minus q and plus q, right? Minus q at b because it's returning, a dash is will be the opposite charge of the a and it's minus q, and b dash will be the opposite of the minus b and c will be plus q. This is minus, all right? And this will be the arrangement, right? For this is the phase A and this is the returning. Distance between these two lines is capital D, and this A dash is the image charge of A, and A is at height h from the Earth, right? And B dash is the image charge of the phase P or line B. Now, using the above concept, voltage difference between A and B will be simply total charge divided by total total voltage. Sorry, we have seen that the two voltage difference. Sorry. Capacitance was the total charge divided by total voltage, right? Now, total capacity to calculate the capacitance, we have to calculate the voltage, and this voltage will be voltage VAB will be simply voltage produced due to the this charge, and this charge, and by cell A. And there will be four terms. This is 1, 2, 3, 4, and this is the charge voltage produced due to charge A. That will be equal to QA upon 2 pi epsilon and DAB by R. We have seen above. Now, charge total voltage due to the B. This will be this one. Total charge voltage produced due to the image charge A dash. This will be equal to this one, and total voltage produced by the image charge B dash. This will be equal to this one, and DAB dash will be equal to DB dash. AB dash will be equal to the B dash, and this will be equal to root of D square plus 2h square. Yeah, this distance will be root of this distance is 2h, h and h, 2h, and this is the distance D. and this uh, right now uh, this okay now what is we can put the value dab dash d and db dash equal to root of d square plus 2h square to this equation, and finally we get 1 upon pi epsilon naught q ln t by r 1 upon root of 1 plus d square by 2h square, and finally we will calculate the capacitance between A and B, that will be equal to the C be equal to Q upon B, be total charge divided by the voltage difference between point A and B, and hence this will be equal to the phi epsilon naught ln d by r 1 upon root of 1 plus d square plus 2h square. Just see very carefully this expression here. If the value of h increase, then this value of denominator will get decreased, and when this denominator will be decreased, then the capacitance will be increased. We can say that the effect of earth increases the capacitance. You have to remember this concept for the gate point of view and also from ES point of view. This is very important formula and concept. If the value of H increase very high with comparative space between the conductor, means if the lines are at very high, the transmission line जब अर्थ के सरफेस से बहुत हाई होगा, उस केस में जो है आप H D by H 2H will be can be neglected. It will be very low value, and this all the root terms will be finished, and due to which it will become simply pi epsilon naught ln upon ln d by r, like previous one. Okay. I hope that it is clear to everyone. If there is any doubt regarding this concept and derivation, you can ask in the group without any hesitation, right? Thank you. Thank you so much.